Hello ho ho and welcome back to Python with another tutorial. Yes, and today we are gonna look at decorators. And yeah, with decorators we are decorating a function. Wow, I guess this won't help you. I mean, with decorator we won't edit the source code of a function we already defined, but can kind of add certain things that will happen before and after the function. Yeah, and it's hard to explain without coding, so let's start coding. So kind of the core of the decorators are function nesting. So in Python it is possible to nest a function inside a function, like this. Of course we have to add brackets, and yeah, we just it's obvious what this code does. It prints 1 because we defined a function inside a function, and we can even define a function inside a function inside a function, and so on. So yeah, now let's use a decorator to decorate our function too. So what is a decorator? Let's first write our first very simple decorator function, def decky, which has a function as an input. And yeah, now we are writing a function inside the function, which we are just calling wrapper, like everyone calls the function inside the function wrapper. And this doesn't have to have arguments, but we are exploring cases or dive into cases where we are working with arguments. And what we are doing now, we write something print hi, and above will happen before the function is executed or the function is called. Now everything will happen after the function. Now we are calling our function, of course in this case with brackets like in every case, and after this we are returning our wrapper, this time without the brackets. And now let's decorate our function too. Add this is a keyword sign for our decorator, the @ sign you use in emails. And now we are writing our decorator, which we called a decky. And now let's just call our function too. Let's execute it, and you see hey is printed even without calling the function decky, because decky is decorating our function too. And by decorating it with our @ sign, everything in this wrapper block will be executed if we are printing like function ended. This will also be executed, and this can be quite powerful. For example, decky time. This is an example I guess everyone will give you if it comes to decorators. Like start time equals time point time, and time equals time point time. This sounds like the apocalypse kind of started. And now let's just print start time minus, no, of course not, end time minus start time, seconds where needed. Let's run our code, and we have to of course use the name of our function correctly, and 0.0 seconds where needed. So let's just do something which needs a little bit more time. Equals a equals 10,000, while a equals a minus 2 pass. Yeah, now we have a time because now it's 0.001999. So the first function was so fast he couldn't even kind of calculate the time which was needed to execute the function. But in this one, yeah, we have time. In C code this would be much less, I guess. But maybe our function isn't a void function. It wants to return something. For example, let's kind of do what can we do? A square root. Let's do a square root. A and oh no, let's just do power of a power of b return a power of b, and yeah, if we now print fun2, it will a fun2 with 1 2. We see wrapper takes 0 positional arguments, but 2 were given. How can we do that? Because it wouldn't make sense to use now the same arguments. It would work if we have AB and use it like this. It kind of would work, but he's returning our wrapper function, which is none, because wrapper does return nothing. We could also say return, let's call this a equals function, and if we return a, we would even get our number. But we are limiting ourselves to say wrapper a b, because now every function that has to be which our decorator decorates has to be this kind of arguments a and b, like this. So if we have, for example, 2 arguments like this one, we should get an exception because it's missing 1 required argument. So what can we do for that? Let's do let's work with arguments and keyword arguments. Like this, 2 asterisks for keyword arguments. And now, of course, we are calling our function with keywords arguments. Let's just copy it. Let's reformat it a little bit. And after reformatting, and why did I wrote brackets here? I don't know. We have to add 1 here. It will work, because now it doesn't matter. We can now use our decorator to any kind of function. We can even decorate, let's write a small function like this, def fun3 takes, for example, a string, and returns a point split b for e in range c. And we can even decorate this function with it. Now, because this wouldn't be good for a showcase, for e in range c d, we can call our new function, use a point, let's write some stuff with points. like this it should work. And yeah, it worked. We kind of, yeah, have the same splitted string over and over again because we wrote a function that takes a string, splits them with a substring b, and yeah, fills a list with it for e in range cd. Okay. So I guess I'm finished. Let me have a quick look on my script I wrote for this video. Yeah, if you have, for example, by Python, you have built-in decorators like we had with our class functions. We can use classes as a function using our decorators. And yeah, other stuff like static functions, you can explore them. But yeah, it's nice if you know how decorators work before, for example, making class functions. And yeah, I hope you kind of enjoyed my video, and yeah, I would say see you in the next video. I wish you a wonderful evening, dinner time, night time, whatever time it is in your country. See you, bye bye, and did I wanted to say anything? No. Bye bye. Hello, ho, ho. Oh, my voice sounds like I'm dying.